All right. So angles of elevation, angles of depression. And all we're doing, all this is doing for us today is giving us a way to set up certain kinds of problems so that we can use SOHCAHTOA. But the nice thing we'll be able to finish our homework in class, and then we'll be able to study tonight. Angle of elevation. What we're talking about here is the angle up from the horizontal. All right, guys, let's stop talking. Angle up from horizontal. So if we draw a picture, just easy, it's an easy idea. So this is our horizontal line. And this is the angle of elevation, going up from the horizontal. So it's a way of setting up angles. The angle of depression. Is the angle down from the horizontal. So if we have our horizontal line here, the angle of depression is going down from the horizontal. So the way that we're going to use these is we might be given a problem that says the angle of elevation from a person on the ground to an airplane is 57 degrees. Or the angle of depression from somebody in the control tower to the airplane on the ground is 23 degrees. So that's how the problem would be set up. That's how they'd be described. And they're telling you, if you're looking down from the horizontal, you're going up from the horizontal. That's really all the angle of elevation is telling us. And then once we know our angle, then we set up our problem using SOHCAHTOA, just like we did for the last set of homework. All right, so all I want to do is go through a couple of examples using angle of elevation, angle of depression. So for the first one, I'm just going to draw a picture, and we want to decide if we have an angle of elevation or an angle of depression. So for this first one, here's our air traffic control tower. And here's an airplane up here. And down here on the ground is a person standing here. And I'm going to draw some angles here. There's my horizontal line there. There's my horizontal line there. And there's the ground, the horizontal line there. So the dotted lines are horizontal lines. And I'm going to call this angle 1, 2, 3, and 4. And we want to, first thing we want to do is categorize these as elevation, angles of elevation, or depression. And then we will talk about how we might see them described in the problem. So first set, which angles are angles of elevation? Which ones go up from the horizontal? 2 and 4, right? We're going up here, and 2 goes up there. So angle 2 and angle 4 are angles of elevation. So that means that angle 1 and angle 3 have to be angles of depression. We're going down from the horizontal. So how might we describe angle 2? The angle of elevation from what to what? This angle. Where does the angle start? Angle 2. The control tower. The angle of elevation from the control tower to the plane. That might be how you would see that one described. The angle of elevation from the control tower to the plane is 32 degrees. That would be talking about angle 2. How about angle 4? How would we describe that one? Angle of elevation from the ground, from a person on the ground, to the control tower. That's could be how we would see it described. How about angle 1? You know it's an angle of depression. The angle of depression from the plane, we're looking down from the plane to the control tower. So that would be the angle of depression from the plane to the control tower. How about angle 3? Angle of depression from the control tower to the person, to the ground, or to a person on the ground, or to the person's shoelace. So that's how we would see these described. So what I want to do next is set up a couple of problems using angle of elevation, angle of depression, just to see how you would see them in a word problem. All right, so for this first example, we have this person that is 120 feet from the base of the tree, from the base of a tree. The angle of elevation from eye level to the top of the tree is 40 degrees. And we know that the person's eyes, so eye level is 5 feet above the ground. And we want to know how tall is the tree. So on these kinds of problems, if they don't give you a picture, always draw a picture. So here's my tree. And here's the ground. And we're assuming that the ground is horizontal, even though my drawing might not look like it. And we're also assuming that the tree is growing straight up. So that's a 90-degree angle. Well, here's this person standing over here. And this person is looking up at the top of the tree. And we know that this is 5 feet. And our angle of elevation is from eye level to the top of the tree. Well, here's the eye level. There's our horizontal segment at eye level. So the angle of elevation here is 40 degrees. Angle of elevation is up from the horizontal at eye level. And it says this person is 120 feet from the base of the tree, so that is 120. So what we're going to do for this problem is look at this red triangle here. We have a right triangle, and we're going to find x. Is x going to give us the height of the tree? What do we need to do at the end to get the height of the tree? Add 5 feet, because that's going to give us how tall from eye level to the top of the tree. So we're going to find x, and then we're going to add 5 feet. Well, now we're back to the kinds of problems we were doing last time, the SOHCAHTOA problem. So which sides of the triangle do we have? What's x? Opposite, adjacent, or hypotenuse? That's the opposite. And 120? Adjacent, next to the angle. Then we think about SOHCAHTOA, and we say which ratio tells us about opposite and adjacent? Tangent. So we're going to use tangent. So we write our equation. Tangent 40 degrees equals the opposite over adjacent, x over 120. Now we're set. Multiply both sides by 120. So we get x equals 120 times the tangent of 40 degrees. Plug that into our calculator just like we wrote it there, and I get 100.69. And our units would be in feet. So the tree equals, we add 5 to this, 105.69 feet tall. So once we set up our problem with angle of elevation, we're back to doing problems, just regular old trig problems. Questions there? Okay, let's do one more with an angle of depression. All right, so this one we have a lighthouse. And the lighthouse is 175 feet above the ground. That's the part of the lighthouse where the people are standing, where the light is. The angle of depression to a ship is 62 degrees. How far is the lighthouse from the ship? All right, so we're going to draw a picture here, just like before. So here's my lighthouse. I didn't do a good job drawing. We're assuming the lighthouse is vertical, so the people that built it made a nice vertical lighthouse. And I wanted to do it like a round top one. There we go, like that, and like that. There, that's what I wanted. There's my lighthouse. And from where the people are standing, that's 175 feet. And then we go out here to a ship. And we want to know how far the lighthouse is from the ship. So I'm going to draw a triangle like so. And I guess this wouldn't necessarily technically be a ship. I guess that would be a boat, right? You know how to tell the difference between a ship and a boat? What I heard is that a boat will fit on a ship, but a ship won't fit on a boat. Okay. That's what I've heard. All right. So here's my question. So we're looking at this triangle here. We're making a triangle like so. Is this angle the angle of depression? One person says yes and no. One person says no. Is this the angle of depression?
Yeah.
Where did we say we found the angle of depression? The angle down from what? The horizontal. Is this the angle down from the horizontal? No. We need to draw a horizontal line here. There's the horizontal line. This is the angle of depression. So the most common mistake people make is trying to say that that's with this kind of problem, that's the angle of depression. The angle of depression goes down from the horizontal. So you always have to have a horizontal line to measure your angle of depression, angle of elevation. Well, we're trying to find this distance in the triangle. How do we find an angle in the triangle from the information we have? You can do two different things. What is this whole angle here? From the horizontal to the vertical side of the lighthouse? 90. So can't we subtract from 90 and get this angle? So what would this angle be? 90 minus 62? 28 degrees. And there's one other thing we can do. What do we know about this horizontal line and this horizontal line? They're parallel. These two angles are opposite sides of the transversal between the parallel lines. So what do we know about those two? They're the same. So that angle would be 62 degrees. So what we see here is the angle of elevation from the boat to the lighthouse is the same as the angle of depression from the lighthouse to the boat. Those two angles are the same. This would be our angle of elevation. So we can use either of those angles to figure out the x, this side of the triangle. So let's use that one and label our sides. X, opposite, adjacent, or hypotenuse. Adjacent, 175, opposite. Which trig ratio tells us about opposite and adjacent? Tangent. So we say tangent 62 degrees, guys, equals opposite over adjacent, 175 over x. This is like our opener now, except we have a tangent instead of a cosine. Multiply, oops, my dealie just died here. Let me plug it back in. You get used to it. All right, so we multiply both sides by x. Those cancel. I get x tangent 62 degrees equals 175, and divide by tangent 62 degrees. And we get x equals 175 divided by tangent 62. So x equals, when we divide that out, 93.05 feet. So the lighthouse is about 93 feet from the ship, from the boat. All right, questions there? Okay. Our homework has two parts. Mm-hmm. I thought you said, can I put one up? No? Can I cut one of them out? All right, so this first part is due in class. And then for the review, page 537, number 1 through 17. And also don't forget that the Common Core and the Algebra review are due Friday also. But everybody's already done with those, right? So those two pieces are due in class tomorrow. This piece is going to be due in class today.